So the atmosphere. Well, the atmosphere is a mixture of gases, mostly made up of nitrogen, N2, with oxygen making up roughly 21%, carbon dioxide, water vapour and other gases making up the balance. So you can see it's mostly nitrogen and about 1/5 oxygen. Properties of oxygen. Oxygen is slightly heavier than air. It's slightly soluble in water, allows fish to breed. It's a neutral gas, so it's neither an acid or a base. Its pH is equal to 7. It relights a glowing splint, and it's a colourless, odourless, tasteless gas. Can I just highlight the relights as glowing splint? That's a test for oxygen. So preparation of oxygen, we prepare oxygen by the decomposition of hydrogen peroxide using manganese dioxide as a catalyst. A catalyst is a substance which alters the rate of a chemical reaction, but are not used up themselves. So the manganese dioxide that we use for this experiment isn't used up. So this is our experiment. We use a tap funnel, that's this thing here, and you open up the tap and you can let the hydrogen peroxide fall down and it hits the manganese dioxide underneath here. Now, the reaction is 2 molecules of hydrogen peroxide with the manganese dioxide gives us 2 molecules of water plus oxygen. Notice the manganese dioxide, it isn't actually part of the chemical equation, it only helps the reaction along. In fact, hydrogen peroxide would decompose, it would break down into oxygen and water on its own anyway, but it just takes a really long time. So you collect it in this, and this is called a beehive stand, and that's how you collect the oxygen. The test for oxygen is you put a kind of a glowing splint, so you light a piece of wood, blow it out, put it into oxygen, and if it relights, it's in the presence of oxygen. Oxygen has got a number of uses. Well, it's required for aerobic respiration, it's needed to burn fuels, and it's also used in welding metals. So in welding, welders use canisters of oxygen to increase the burning, so we have more energy to weld. The carbon dioxide is similar enough. It can be prepared by reacting calcium carbonate, which are just marble chips, with dilute hydrochloric acid. Now this is the chemical formula for that. Calcium carbonate is CaCO3, hydrochloric acid is 2HCl, and it gives calcium chloride, water and carbon dioxide. And this is what the experiment looks like. You can collect it in the same way as before. The only difference is that tap funnel now contains hydrochloric acid, and D is the marble chips, and the marble chips should be white there because marble is a white chalk-like substance, chalkish. And this is how you collect it. Again, carbon dioxide and water, they're slightly soluble in water, but most of the carbon dioxide makes it up through this trap, and we're able to store it like so. Properties of carbon dioxide. It's colourless, odourless, tasteless gas, same as oxygen. It turns lime water milky. That's the important one. That's the test for carbon dioxide. It doesn't support combustion. It's used in fire extinguishers. It's slightly acidic, so it is a pH between 0 and 7. So it's slightly acidic. It's not basic like water is. It dissolves in water and it forms carbonic acid, fizzy drinks. It's more dense than air, and it's slightly soluble in water. The test for carbon dioxide is that it turns lime water milky, so even if I take air from the atmosphere and pump it through lime water, eventually it will turn milky. Uses of carbon dioxide, it's used, dry ice is the same thing as carbon dioxide, it's used to make a smoke effect in horror movies and in stage performances. It's used in fire extinguishers and fizzy drinks, in refrigeration in the form of dry ice. Photosynthesis, plants take in CO2 through the stomata on the underside of the leaves. Water vapour is another test we can do for in the atmosphere. Now, if you leave a cold can out on the table, you'll notice that condensation will form on it. The reason condensation forms on it is because the can is cold, so any moisture in contact with it condenses, so it changes from a gas to a liquid, and that's the atmosphere.